Good morning, students. I welcome you all to a new class in physics today. In the previous class, I picked up motion in one dimension and I explained to you that when is a body said to be at rest and when is it said to be in motion with respect to its immediate surroundings. We also discussed that how motion and rest are relative terms. Okay, and then I also explained to you about distance and displacement, speed and velocity, and its types, and we compared the terms. Now in today's class we are going to look at another set of terms, that is acceleration and retardation, and both these physical quantities are related to motion. Okay, now children, let us look at what is acceleration. Acceleration is a rate of change of velocity with respect to time. And even retardation is a change in velocity with respect to time. Then basically, what is the difference between the two? When I say that the velocity of the body is increasing with respect to time, it is said to be an accelerated motion. And when I say that the velocity of the body is decreasing with respect to time, it is said to be a retarded motion. Both of them are vector quantities as they involve magnitude along with direction, and acceleration is represented by a small a with an arrowhead, while retardation is represented by a small r with an arrowhead, or it could also be represented as negative a. Now let us look at why is it negative and why is this positive. I told you that let us pick up an example of a car which is moving on a highway. Now, when the car is speeding up, you can see that the velocity of the car goes on increasing with respect to time. That kind of a motion, when the velocity increases with respect to time, is said to be an accelerated motion. And therefore, the acceleration is found out by using the formula v minus u over t, where v represents the final velocity, u represents the initial velocity, and t is the time. But what about retardation? When brakes are applied to a vehicle, it is said to have, it will show a decrease in velocity. And therefore, it is said to have a negative acceleration or retardation. And it is also calculated by the same formula, v minus u over t, but the value would be negative because the value of u is greater than the value of v in case of retardation. So therefore the acceleration is negative. But in case of acceleration, the value of v is greater than u. So therefore it is positive in nature. Okay. Now irrespective of whether it is acceleration or retardation, the formula remains the same. The SI unit remains the same. SI unit for both acceleration and retardation is meter per second square. The higher unit could be kilometer per hour square and the smaller unit could be centimeter per second square. But it is very important for you to remember that acceleration is basically an increase in velocity, while retardation is a decrease in velocity with respect to time. And from this formula, a is equal to v minus u over t. If we cross multiply, we get a new formula, v is equal to u plus at, which is considered to be the first equation of motion. Okay, I hope you have understood the basic concept or differentiation between acceleration and retardation. Okay, now let us look at the different types of acceleration. The first one is uniform acceleration. From the name, it is very clear that when there are equal changes in velocity, whether it is an increase in velocity or it is a decrease, it should be an equal change in velocity with respect to time in equal intervals of time. For example, if I say that a car is showing a steady increase in velocity of 10 meters per second after every half an hour, it is increasing by 10 meters per second. That is, in the first half an hour it is 10 meters per second, in the second half an hour it is 20 meters per second, in the third it is 30 meters per second. So what is happening? There is a steady increase in velocity and it is also equal change in velocity with respect to equal intervals of time. So it is said to be uniform acceleration. The best example of uniform acceleration is a freely falling body under the force of gravity. When a body is pulled by the force of gravity of the earth, what happens is the velocity of the body goes on increasing as it falls towards the earth. And that is said to be a uniform acceleration or a uniformly accelerated motion. Now let us look at what is variable acceleration. If the change in velocity is not same in the same intervals of time, it is said to be a variable acceleration. The best example is a vehicle which is moving in a crowded area. Sometimes the velocity would increase and sometimes it would decrease, and that too if it increases, it won't increase at a steady rate. Sometimes it would increase, say for within an half an hour's time, it increases by 10 meters per second. In the next half an hour, it could decrease by 5 meter per second, while in the next half an hour it could increase by 20 meters per second. So there is a very it's not a uniform increase or a uniform decrease. That is said to be a variable acceleration. Now we come to the third type of acceleration, which is called acceleration due to gravity. Now we all know, children, that every object, when we release a body from a height, it always falls towards the earth. Why? Because the earth is attracting the object towards its center by a force of gravity, which tends to pull the object downwards. And when a body falls freely under gravity, it is said to possess acceleration due to gravity because its velocity is increasing. So it is said to be acceleration. And why due to gravity? Because it is under the force of gravity of the earth that it is falling. Now it is very important for you to know that when the body or when the object is falling towards the earth, the value of g is positive and it is considered to be 9.8 meters per second square. And when an object is thrown upwards, that is against the force of gravity, then the value of g is considered to be negative because it is opposite to the force of gravity. Remember this. So when I say that a body is falling towards the earth, the value of g will be plus 9.8 meters per second square. And when the object is thrown upwards, the value of g would be minus 9.8 meters per second square. So we looked at the different types of acceleration. After this, we pick up a very, very important topic. That is acceleration due to gravity. I want to elaborate more on it. Actually, the value of acceleration due to gravity, which is denoted by small g, is maximum at the poles and it is minimum at the equator. Now, this is a statement which has to be explained. In order to explain this statement, let us look at this diagram. I have drawn the diagram of the earth. The earth is not a perfect sphere. It is egg-shaped. Okay, it is flattened towards the equator. It is the distance of the ends of the equator is more from the center than the distance from the poles. Poles are closer to the center of the earth, the North Pole and the South Pole. They are at a shorter distance from the center of the earth than the equator. So I said that the value of g is maximum at the poles and minimum at the equator. Now let us understand this why, as to why. As I told you that poles are closer to the center of the earth and the equator is away, far away from the center of the earth. Now here I would like to tell you something about Newton's universal law of gravitation, which actually we are going to study in the next chapter. But here I would need to explain this to you in order to understand this point. So in short, I will explain it to you. According to Newton's universal law of gravitation, if there are 2 point masses lying on the surface of the earth and they are separated by a distance of r, small r is the distance of separation between 2 point masses m1 and m2. Then according to Newton's universal law of gravitation, the first object exerts a force of attraction on the second, and the second would exert a force on the first, such that the force of attraction exerted is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay, I repeat, every object on the earth exerts a force on the other. So the force of attraction of the first on the second and the second on the first, there is a mutual force of attraction, is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Why is it called universal law? Because it applies not only to the objects on the surface of the earth, but also it applies to the objects in space. That is, it applies on the different planets which are present in space. We will study about it in detail in the next chapter. So if I replace this proportionality sign with a capital G, which is called the constant, gravitational constant, it is F is equal to G m1 m2 upon r square. We also know that force is equal to mg. This is another formula for force, that is mass into acceleration due to gravity. Now, if I substitute this F is equal to mg part here, I get mg is equal to, in place of m1, m2, I take gm upon r square. Now, what does this stand for? You understood why I took mg here? Because F is equal to mg. So, I substituted it here. And I took g. And why did I take m upon r square? Here, m refers to the mass of the earth and r refers to the radius of the earth. Okay. Now, when I when I look at these two things, what is common is the mass. So I just cut out the mass. The mass of the body is cut out. Okay. So what do I just look at this relation. Okay. G is a constant. G is basically a constant, gravitational constant. Now, if I see what is the relation of acceleration due to gravity with respect to the radius or the distance, it is inversely proportional. Can you see? The value of g, that is acceleration due to gravity, is inversely proportional to the distance of a particular object from the center of the earth. This is what I am looking at. This is the main thing which I want you to understand, that the value of acceleration due to gravity is inversely proportional to the distance from the center of the earth. Now, when I go to the poles, what did I tell you, children? I told you that the poles are closer to the center of the earth. And as the distance of the poles is less, the value of G will be more at the poles. Okay. And as the distance of the equator from the center of the earth is maximum or is more, the value of G will be less or it would be minimum. So I hope you understood this. Once again, the distance of the poles from the center of the earth is less, and we know that the value of G is inversely proportional to the distance of a particular object or a particular point from the center of the earth. When the distance is less, the value of G is more, and when the distance is more, the value of G would be less because it is inversely proportional. So therefore, we say that I come to the statement which I gave you, that the value of G is maximum at the poles and minimum at the equator. Okay. Now look at this next statement. The value of G decreases with altitude and also with the depth from the Earth's surface. Again, here the same point I would like to repeat. The value of G decreases with altitude because when the altitude increases or the height increases, what happens? That is, the distance from the center of the earth increases. And when the distance increases or the depth increases, the distance increases, what will happen to the value of G? It would decrease. Because just now I told you that the value of G is inversely proportional to the distance from the center of the earth. So the value of G decreases with altitude and also with the depth from the earth's surface, and it is maximum at the poles and minimum at the equator. So you should be able to explain both the statements in detail. This is very, very important for you to understand. And moreover, I would also like to tell you one more thing, That is, the value of g at the center of the earth is 0. Why is the value of g 0? Because I told you that it is proportional to the square of the distance. So at the center of the earth, what is the distance? The distance is 0. So therefore, the value of g at the center of the earth, because the force of gravity is pulling the object towards the center. So what is going to happen to the value of g when the distance is 0? The value of g is also 0. Okay. Now, here I have put down a fact that two bodies of different masses, when dropped from the same height, they reach the ground simultaneously in vacuum. Now, basically, what is vacuum, children? When there is no air. Now, when there is no air and you drop two objects of different masses, okay, and from the same height. The question is, when you drop a stone or a bunch of feathers. Let us consider with an example. Suppose you take a stone and you take a bunch of feathers, okay, and you drop both of them from the same height, but they are dropped in vacuum. So what does this statement say? That they will reach the ground at the same time. Why so? Why so? Because in vacuum there is no air. And if there is no air, what is going to happen? There will be no friction with the air, and also there will be no buoyant force of the air acting on the objects to restrict its motion. Actually, these two, friction and buoyant force due to air, are the two factors which actually limit or slow down the motion of these two objects. So in vacuum, when there is no air, there is no friction and there is no buoyancy due to the air. So due to which both the objects will fall at the same time on the surface of the earth. Okay. And G is acting on them. Even if there is vacuum, the value of acceleration due to gravity is acting on them because they are on the earth. Okay. Now, I am going to put up a question for you and I want you to find out the answer to the question. I have explained half of the question to you. My next question is that now I remove the vacuum condition and I drop a stone and a bunch of feathers from the top of a building. And my question to you is that out of the stone and the bunch of feathers, which would fall first to the ground? Definitely both of them are not going to fall at the same time simultaneously. There's going to be some difference. Okay, so now this is food for thought for you. You are supposed to find out the answer to this, and I'm going to take up the answer and discuss it in the interactive class. That is, my question is, I repeat my question. When you take a stone and when you take a bunch of feathers and you release them from the same height, okay, not in vacuum but in a normal condition, okay, so which out of the two will fall first to the ground and why? And if you want, you can also try it out. You can go to the second floor or the third floor or a height and drop a feather and a stone simultaneously and observe what is your observation, and we can discuss about it in the interactive class. Okay, so this is very, very important for you to understand about acceleration due to gravity and how does it vary on the poles and at the equator. It is based on the Newton's law of gravitation, universal law of gravitation, which we will study in detail in the coming chapter. So in order to sum up with this, we end up the unit 1 of the chapter, children. Unit 1 of the chapter, motion in one dimension, is done. Okay, and after this unit, there are a set of numerical problems which I will be solving in the next class. Okay, and for your information, I'm telling you that unit 2 has been deleted from the syllabus by the ICSE board this time. So we will not be doing unit 2. We are doing unit 1, and after this I will do the numericals. Okay, so a quick recap of what we did today. First of all, I discussed about acceleration and retardation with you, and I told you that acceleration is positive because the final velocity is greater than the initial velocity, and retardation is negative because the initial velocity is greater than the final velocity. Then I taught you the different types of acceleration: uniform acceleration, variable acceleration, and acceleration due to gravity, in which we discussed that when the body is falling freely, the value downwards, the value of g is positive, and when it is thrown upwards against the force of gravity, the value of g is considered to be negative. This is taken for to solve the numerical problems. That's why I'm doing it with you. Okay. Then I discussed with you that the value, these two strong statements, that is, the value of g is maximum at the poles and minimum at the equator, and it decreases with altitude and depth. What is the reason? The reason is the same. That is, the value of g is inversely proportional to the distance from the center of the earth. So as the distance increases, the value of g would decrease, and when the distance decreases, the value of g would increase. And the value of g at the center of the earth is 0. Okay. Then I also discussed with you that when two objects of different masses are dropped from the same height towards the ground, but in vacuum, they reach at the same time. And I quoted the reason for it, that there is no effect of friction and buoyancy because there is no air in vacuum. And I put up a question for you, which I want you to answer. That is, when you release a stone and a bunch of feathers at the same time from the top of a building, or maybe from a height, simultaneously in air, out of the stone and bunch of feathers, which falls first to the ground and why? Okay. So with this, I end my class today, and I want you to go through all the topics taught carefully and note down your doubts, which will be taken up in the interactive class. Thank you, children.